Okay, in this tutorial video, we're going to take a look at electron configurations. And basically, electron configurations are a way to describe where the electrons are located for an element. Okay, so if we started just out with the basic, let's say hydrogen. Okay, we know that hydrogen has one electron. So where is that electron? All right, and before when we talked about electrons, we know that they were kind of surrounding the nucleus, and for a while we thought that they were kind of, you had your nucleus, which had your protons, so we'd have one proton here, right? And depending on the version of hydrogen, we would have either 0 to 1 neutron. So that's the nucleus, and this electron's somewhere around it. And for a while, again, we talked about orbiting the nucleus. Okay, forgive my drawings there, oops. So we talked about that, but then we found out that the model kind of push more towards this electron cloud model, this probability, saying, hey, what's the likelihood of finding electrons this close to the nucleus or this far from the nucleus, things like that. And the way of drawing those probability models kind of came in the form of what are called orbital clouds. So the most basic, kind of the primary first level orbital is the 1s, and it's a spherical shape. Okay, so it's a 1s orbital. So each orbital, as we get into it, can hold up to 2 electrons. Okay, now your s orbitals will always just hold 2 electrons, but you can have different s orbitals on each successive energy level: 1s, 2s, 3s, 4s, 5s, right? And I'll keep going. Then there are the p sublevels. So the p orbitals can have 3 orbitals, okay, each again holding 2 electrons, so 6 electrons total. And then you've got your d orbitals, okay, and then your f orbitals holding respectively 5 orbitals, 7 orbitals, which means 10 electrons and 14 electrons. So there's an order to this, right? So as we go through, and you'll see a couple of other kind of schematics and diagrams based on it, but I'm going to close with one, just showing you the periodic table, which you'll always have to kind of help you along the way. But first of all, if we had a different element, let's say boron, okay, which has, let's take a look, boron has 5 electrons, all right? So it's going to fill up the 1s orbital. So if I were to do boron right here, this would be 1s2. So boron, 1s2. I've got 3 more electrons to go, so I go to the next sublevel, 2s2. Okay, that's 4 electrons. And then the next level is the 2p's, but I only have 1 electron left. So it'd be 2p1. Okay, the next element, which is carbon, right next to boron, has 6 electrons. So it would just be the same thing, except now I have an extra one in that 2p. Now, when we look at 2p's, if I were just to kind of draw this out for the carbon, what they're going to do is they're going to fill up individually first before they then start doubling up. So nitrogen would be 1s2, 2s2, 2p3 there. Okay, but then oxygen, which is 1s2, 2s2, 2p4, would start doubling up then. Okay, so you'd have 2 electrons in a orbital and one of your 2p orbitals there. All right, so then let's take a look at something a little more challenging. So we go up to down here, we can see kind of the electron configurations, and we see again sodium, and this is just written out just as I had above the orbitals, but just in a line. So again, 1s2, 2s2, 2p6, 3s1. Okay, so how about something like chromium? All right, now chromium is actually really cool because it has a special stability, which we'll get to in a second, but that's got 24 electrons. So let's build up again. All right, 1s2, okay, 2s2, 2p6, okay, 3s2, 3p6, 4s2, and now, and this is the weird part, but we actually didn't go to the 3Ds until after the 4s. And I'll show you again another visual tip to kind of remember that. We now go to the 3D. So technically, chromium is actually 3D4, all right? But I will say there's a special stability. If we look at the 3D, there's 5 orbitals in there, okay? And we're saying it's got 4 electrons, 1, 2, 3, 4. Well, it's like, hey, I'm so close to getting a half-filled orbital. It's like when you collect something, you're like halfway there, you get a little extra happy, a little, something special about that. So what we're going to do is we're going to take away 1 from the s and put it in here. So it would be 4s1, 3d5. So that happens to people like chromium, such as molybdenum or tungsten. And also you'll see that again when you get to copper, silver, and gold. Okay? But now let's talk about, so how did I know, besides teaching this forever and taking it as a student way back when, how did I know like this order? Okay, now there are schematics to kind of help you that. I used to learn like a little chart I'd write out such as this, and you can just take this and you just write all the orbitals out, okay, and I would just keep going, and what you would do is you would go from diagonally, okay, like this, 1, 2, oops, that's not right, okay, like this, 1, 2s, upward. Sorry, see, I haven't done this well because I don't need to use it anymore, but 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, and so on. Okay, so you go diagonally from bottom right to upper left. Okay, so that's way back when I was in high school. That's how I learned it and memorized it. But for some reason, I don't know, my teacher didn't show me this other way. But basically, you can get it all from the periodic table, right? You'll always have a periodic table on your chemistry test, whether it's AP or honors or whatever. So it's all here. You'll note your periodic table is divided into groups. You have your S block here. You've got your P block here. When I say blocks, I mean like groups of 2, because remember the S orbitals can only hold 2. The P's can hold 6, right? The D's can hold 10. And if the F block were here, if my periodic table showed it, it would have 14. And then you just go as you go from left to right. So if we were doing, let's say, silver, which is 47, we go 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d9. Okay, but remember, so I'd end with 5s2, 4d9, but really I'd probably take one away to get a special stability. That's a really special stability, right? Because I have a full 4d sublevel. I'm so close with that 9 electrons that, hey, I'll take one from the 5s, okay? Because that's only a 2 electron orbital, and I'll donate it here to make a full 4d sublevel. All right, so that's what I mean by using the periodic table to figure out the order. And that may take time, so you may go ahead and start using something like this, or you may use a cheat sheet to kind of remember the order as you practice. But once you get the hang of it, once you start writing more configurations out, you'll learn that kind of that's the order. So in a nutshell, again, that's electron configurations, talking about where these electrons are located in it for an atom, and you can draw any electron configuration now for any element just using the periodic table and knowing how many electrons there are. Hope that helps.